Central tendency, the mean and the mode. So what is central tendency? A measure of central tendency is a measure intended to represent in some way what is common, typical, or ordinary of a group. However, data points in different types of groups are measured in different ways, so using the same measure of central tendency isn't always possible. Central tendency is one of the main descriptors of any group of data points or measurements. It's meant to give you a sense of what is generally going on in your data, at least in one respect. The three most common measures of central tendency are the mean, median, and mode. What's the mean? There are actually several types of means, including the arithmetic mean, geometric mean, quadratic mean, and so on. Most of the time, however, when people simply address a mean as the mean, they're talking about the arithmetic mean. The arithmetic mean is what you probably learned to call the average in grade school. You add up all the values you have and divide by the number of values you have, and that is your mean. So what's the population mean? This type of mean is usually represented in one of two ways to denote where it comes from. When a mean comes from a population and represents every single individual in a population of interest, or is otherwise a definitely known value, not an estimate, it's represented with the Greek letter mu, written as that symbol right there, mu. This is called the population mean. So anytime you see mu, expect that it is mean and that it is a known value for the group being talked about, not an estimate from a sample. What's a sample mean? If, on the other hand, a mean comes from a sample, then it represents data points collected for the purpose of estimating what is likely to be true of the population of interest. In that case, it is denoted by this symbol, an X with a bar on top, and called X bar. Both mu and X bar are calculated in the same way. They are the sum of measurements divided by the number of measurements. The only distinction is that one symbol indicates that its data came from population data, and the other indicates that its data came from a sample. The formula for the mean is often written as sigma x divided by n, where an uppercase Greek sigma represents the sum, x represents the data point, and n represents the total number of data points. So another way of reading that formula is just the sum of all your x's divided by n, or the number of x's you have. So why not always use the mean? Sometimes data points don't naturally exist as countable numbers with real measured value. For example, think of all the jersey numbers of players on a sports team. Those numbers only serve to indicate that one player and another player are not the same player. In other words, sometimes the things we use to identify individuals, even when they are numbers, are really just labels, or essentially names, with no order or real measurement to them. It wouldn't be terribly meaningful, for example, to ask what the average jersey number is on a team. Who cares? In cases where there aren't real, measurable, countable values with any sort of order, like the numbers on sports jerseys, numbers effectively serve as names or labels. With any set of value, where data is recorded for names or labels without order or measure, even though it doesn't make sense to calculate a mean or average, there is still a measure of central tendency available to summarize what is common or typical in a set of data points, the mode. The mode represents the most common or frequent value in a data set. So the mode's the most frequent or common value in any set of measurements. For example, if there are several people with the same name, you might ask, what's the most common name? For numbers on a sports jersey, you would expect every player on a team to have a different number. So within a team, there might be no mode. Well, it probably isn't. In a league, however, there might be a very popular number, like 12, for example. And if it's more popular than any other number, then it is the mode. Or if you have groups of animals, like cats, dogs, chickens, and ducks, and there are more ducks than any other animal, then the mode is duck. Or if you look around and the most popular shirt color is purple, the mode is purple. Things can be multimodal as well. For example, let's say there are 2 cats, 4 dogs, 6 chickens, and 6 ducks. What's the mode? This is actually a bimodal situation in which there are 2 modes, chickens and ducks. In other words, 2 values stand out above all the others. If there were 8 cats, 8 dogs, 8 chickens, and 6 ducks, it would be called multimodal, where 3 or more values stand out above all of the others. What happens, though, if there are 6 cats, 6 dogs, 6 chickens, and 6 ducks? What's the mode? Here we're back to a situation where we have no mode at all. No group stands out from the others. No group or groups aren't most common or frequent. So there's no way of describing what's common and what isn't. There's just no mode to speak of.